Good morning, class. Today we are going on to chapter 7 of your A Maths, and that is on coordinate geometry. Okay, coordinate geometry, and we are starting with section 7.1, parallel lines. Okay, now before I go on to parallel lines, I want you to take note that there's something called the angle of inclination. Okay, angle of inclination as given on page 157 of your textbook. Okay, now what is the angle of inclination? Is the angle theta here, whereby the line makes with the positive direction of the x-axis. Okay, so this will be the angle of inclination for this point, and for a line slanting this way, this will be the angle of inclination for this particular line. Now, what has the angle of inclination got to do with the gradient? Okay, now if you read through page 157 and page 158 of your textbook, it says that the gradient m of a line is given by m equals to tangent theta, where theta is the angle the line makes with the positive direction of the x-axis. Okay, so the important thing here is to know that the gradient m is actually given by tangent theta. Okay, so this is the relationship for the angle of inclination to the gradient of the line. Okay, now I'm going to show you what it means here. Alright, let's look at the first situation. Okay, the first situation whereby the line slant this way. Okay, the line slant this way. Alright, now we know that a line slanting this way has got positive gradient, and gradient is given by rise over run. Okay, now if I consider this triangle, this is the rise, this is the run. Now according to Tuakaso, tangent theta is opposite over adjacent. So opposite over adjacent, okay, will give me tangent theta, and this will give me the gradient, which is equals to m. Okay, which is equals to m. So note that because this is slanting this way, this m is a positive value. It's a positive value. Okay, now let me go to the second situation. Now this is the second situation. Now if the line slopes this way, okay, this is theta, because it's the angle that the line makes with the positive direction. But note that this is angle little a. Okay, little a is an acute angle. So this is an obtuse angle. Now we know that the tangent of an obtuse angle is negative, while the tangent of an acute angle is positive. So let's take a look at the acute angle. So if I want to find the tangent of this angle, is still opposite over adjacent, which is rise over run, but I'm referring to this line, so I need to add a negative sign because the gradient of a line slanting this way is negative. Now don't forget, tangent A, tangent of an acute angle is positive, but because this is an obtuse angle, I got to add a negative sign. So this will be equals to the gradient, and this gradient here is a negative value. Okay, because the line is slanting the other way, and tangent of an obtuse angle is negative. Okay, now I will explain this further by bringing you back to one of the concepts that we have done in our E-Maths, or rather our A-Maths. Now remember, I said that angles that are in this quadrant here, okay, remember the CAST, this one is all positive, this one is sine positive. Now if it's an acute angle, the tangent will be positive. Okay, tangent of the angle will be positive. Okay, now if I have an angle over here. Okay, now let me just change my pen. If I have an angle over here, this is an obtuse angle. Okay, let's call this obtuse angle red theta, and this is angle little a. Remember, we call this the basic angle when we did chapter 6 in E-Maths. So the tangent of this is equal to tangent of this, but the tangent of this, because it's in the second quadrant, only sign is positive. Therefore, tangent of the red theta is a negative value. Okay, but the value, the numerical value is the same. That means tangent A and tangent theta, the numerical value is the same, but tangent A is positive while tangent theta is negative. Okay, so this is what we have in chapter 6 and is translated into this particular section. So I'm going to repeat now. For this particular case, if it is an acute angle, the gradient will be positive. Okay, if it's an obtuse angle, the gradient here will be negative, but we can take it with respect to the acute angle because this is a positive value, this is a negative value. We just need to add a negative sign here, so we will make the gradient negative. Okay, so this is the first part of the section here. Now, before I go on to example 1, I want to make sure you know this. Now, we know that parallel lines have the same gradient. That means the angle of inclination is the same. So even if the line is this way, even if the line is on this side, because it's the same as this parallel, the angle of inclination will be the same. Likewise, if it's slanting this way and you have a line that is parallel, the angle of inclination will also be the same because both lines will have the same gradient. Okay, I just want you to take note of that. We can always make sure that it makes the angle theta with the positive x-axis because there will be a line that is parallel to this and the angle of inclination will be the same. Okay, so this will sum up the concepts that we have here. Now I'm going on straight to example 1 first before I summarize this part, the important part of this particular section. Now example 1 says that find the acute angle that the line segment joining A 1 negative 4 and B 5 4 mixed with the positive direction of the x-axis. Now it's always good to draw a sketch of the 2 points. Now you want to find the angle of inclination, that means it's theta here. Now if we join these 2 points with a right angle, you will realize that these 2 are parallel lines and these 2 are corresponding angles, so they are the same. So if I'm able to find this angle, I'm able to find this angle. Okay, now just now we learned that gradient of AB is, we learned in E-Maths that gradient of AB is y2 minus y1 over x2 minus x1. So we apply the gradient formula, we get the gradient of AB as 2. Just now we also learned that gradient is equals to tangent theta. Okay, gradient is equals to tangent theta. So I will write down tangent theta is equals to 2. Then I key in tangent inverse or tangent negative 1, I'll get the answer. So the angle of inclination will be 63.4 degrees. 63.4 degrees. Okay, now one thing to take note is that parallel lines have the same gradient. This is one way. The other direction will be the converse. Lines with the same gradient are parallel. So these 2 facts we have to bear in mind. Okay, so for example 1, when we want to find this angle, is equivalent to finding this angle because they are the same. They are corresponding angles, parallel lines. Okay, so that will conclude your example 1. Alright, now next. Okay, you are to read through page 159 yourself because what they are telling you is that parallel lines have the same gradient or lines with the same gradient will be parallel, as what I have said in the previous part. Okay, now I'm going right on into example 2. Okay, example 2 says this. Determine whether the lines AB and CD are parallel. Give reasons to support your answer. Okay, first of all, we find out the gradient of AB for part A. Okay, we apply the gradient formula, we'll get negative half, and we find the gradient of CD, we also get negative half. Then you must conclude, since the gradients are the same, AB and CD are parallel. Okay, that will be your part A. Now for your part B, when you apply gradient formula for AB and the gradient formula for CD, you will realize that AB is negative 1 and CD is 1. Okay, now these two gradients are not equal, so therefore AB is not parallel to CD. Okay, please bear this in mind. Alright, so that will complete our example 2. Now next, we are going on to example 3. Now example 3 is quite similar to what we have done in our Emacs. Collinear points are points which lie on the same straight line. Now, to prove that 3 points are collinear, there are 2 conditions. First of all, you need to prove that the gradient are the same. And the second thing is that you must state that there is a common point. Okay, so first we find gradient of PQ, we apply the formula, we find that it's 1. Then we find the gradient of QR, we apply the formula, the answer is still 1. Okay, then when you conclude, you must say, since the gradient of PQ is equals to the gradient of QR and Q is a common point, okay, P, Q and R are collinear. The important thing is you must also state that there is a common point in order to prove that 3 points are collinear. Okay, so that will be your example 3. Alright, okay. Right now, I'm going to the homework. Okay, I'm going on to the homework and I want you to take note of the homework that you are supposed to do. Okay, for homework in the notebook, alright, you have these questions 1, 2, 3, 4, 5, 8, 9, 12, 16. Now note that question 1, 2 and 3 are not going through. Okay, on the foolscap paper, you're supposed to do questions 6, 7, 11 and 13. Alright, so this will be the set of homework that you'll be doing for me. Okay, now please make sure you go through the solutions of the homework after you have tried the questions and not copy straight away from the video. Okay, now for question in the notebook, I will go through the question in the notebook first, then I will go through the questions on the foolscap paper. Okay, now let's look at question number 3. Though I say I'm not going through, I'm going to give you a hint. Okay, now we know that y is equals to mx plus c for a straight line. We must make sure we rewrite the equation in terms of y equals to something, then we can conclude that the gradient is negative 2, and then you carry on with finding the equation of the line. Okay, likewise for part B, we have to find that y is in terms of x first, make y the subject, and therefore we can conclude that the gradient is negative 1/3, and then we continue to do the question to find the equation of the line. Okay, this is a common mistake that students will make. They forget to put y as a subject before they find the gradient. So please be very careful when you do this type of questions. Okay, next I'm going on to question 4. Okay, let's look at question 4. Question 4 is actually quite a straightforward question. Okay, it says that the points A, B and C lie on the same straight line. Find the value of C. That means the gradient of AB will be equals to the gradient of AC. Then after that, you equate the two of them and you solve the equation. You will get your answer as C equals to 4. C equals to 4. Okay, so that will complete your question number 4. Okay, next we move on to question number 5. Okay, now this is a question that will connect some of the topics or some of the chapters together. Okay, that will complete the chapters, that will combine the chapters together. Now it says that the point P23 lies on the line, this particular line, which intersects another line at the point Q. Find the length of the line segment PQ. Now we know that P is 2, 3. We have the first line and the second line, and these two lines intersect at Q. Okay, so I got to solve these two equations in order to find the coordinates of Q. So I solve these two simultaneous equations. I will get x as -2, y as 0. So my coordinates of Q will be -2, 0. Okay, -2, 0. So I apply the length of line segment formula, and I realize that I will get 5 units. Okay, this is applying the length of line segment formula, and you have to know it because we have already done it in our EMAS. Okay, that will be our question 5. Next, I'm going on to question number 8. Okay, number 8 looks very scary, but actually it is not. So let me explain question 8 to you. The intercepts of a straight line at the axis are equal in magnitude but opposite in sign. Given that the line passes through the point 4, 5, find the equation of the line. Now, I want you to look at this line. Okay, look at this line that I've drawn. The line must slant this way because the question says that the magnitude of the intercepts are the same, but they are opposite. Okay, now A, it cannot be this line, because if it's this line, then both of them are positive. So this is not correct. Okay, the diagram has got to be like that because they say that the intercepts have opposite signs. Okay, so the gradient is rise over run. If you realize that this is A units and this is also A units. A over A is 1, so y equals to x plus c, and then we substitute these coordinates inside, we find c as 1. So the equation will be y equals to x plus 1. So this is the equation of the line that we're supposed to find for question 8. Okay, let's move on to question 9. Now, let's take a look at question 9. A straight line passes through the point 4, -3 and makes an angle of 45 degrees with the positive direction of the x-axis. What is the equation of the line? Now remember, I said gradient is tangent theta, which is tangent 45 degrees in this case, which is 1. So the gradient is n equals to tangent theta, which is tangent 45 is 1. So the gradient is 1. So y equals to x plus c, because the gradient is 1 here. Then we substitute the point, this point here, 4, -3 into the equation. We find that c is -7. Therefore, the equation of the line will be y equals to x minus 7. Okay, so this will conclude your question number 9. Okay, we will move on. The next question is question number 12. Okay, let's look at question number 12. Show that the points, they give you the coordinates, are collinear. Now, I will let the points be A, B, and C so that I will refer to them, I can refer to them easily. Now, so what I do is that I find the gradient of AB by using the gradient formula. Okay, now when you reach this point here, A minus B over B minus A, you must be careful. This is a flip, so I can take out a negative sign. I factorize this. A minus B, A minus B. B minus A is actually negative bracket A minus B. So if I were to cancel this, I'll get -1. Okay, so gradient of AB is -1. Let's find the gradient of BC. Now, if I apply the gradient formula will give me until here Now realize that this is a flip, therefore I can take out, factorize this, and this will also give me a -1. Now you'll realize that these two gradients are the same. Both are equals to -1. So we have, since gradient of AB is equals to gradient of BC, and B is a common point, A, B, and C are collinear. We must prove that the gradient are equal and there's a common point before we can conclude that they are collinear. Okay, these are the 3 points that you need to know. Okay, that will complete our question number 12. Okay, question number 16. Okay, question number 16. Let's take a look at the question. A rectangle has an area of 40 square units and a perimeter of 26 units. Its sides are horizontal or vertical. The coordinates of one vertex is -3, -5. Given that the origin lies inside the rectangle, the origin is inside the rectangle, okay, find the coordinates of the vertex that is diagonally opposite to -3 and 5. That means we are supposed to find the coordinates of this point here, okay, the diagonally opposite vertex. Alright, now first of all, I let this length be A and this width be B. Now we will form the equation. Area A times B is 40, perimeter 2A plus 2B is 26. Now I'm going to solve this simultaneous equation. Equation 1, equation 2. I divide this throughout by 2, I'll get equation 2. Then I'm going to substitute in solving the simultaneous equation. Okay, I will get 2 answers for B. It's either 8 or 5. Okay, now when B is 8, A will be 5. When B is 5, A will be 8. I call this case 1, case 2 because I do not know which one works and which one doesn't work. Okay, now you always have to check which one works and which one doesn't work. Okay, now let's look at case 1. Okay, now this is case 1. Case 1, we have -3, -5. Now if this is 5 units, I will have this x coordinate as 2 because we moved 5 spaces, but the y coordinate remained the same, so it's -5. And we move upwards 8 units, so -5 with 8 units will give me 3. The x coordinate remained the same because it's vertical. Okay, now we realize that in these 2 cases here, the origin lies inside the rectangle. Okay, now let's check case 2. Let's check case 2. Case 2 will have 8, 5, the other way around. Now if this is 8, I will have 5, and the y coordinate is still -5 because it's on the straight line, horizontal line, and I move 5 units up, I will get to 0. It's because the x coordinate is the same, move vertically up, 5, 0. Now if we realize this, the point 0, 0, which is the origin, will lie on the on the rectangle and not inside the rectangle. It is not inside the rectangle, so this case will be rejected. Okay, so we only want this case. So the coordinate of the vertex that's diagonally opposite -3, -5 will be 2, 3. So only this particular case is accepted. Okay, the other case 2 will be rejected due to the condition that the 0, 0, the origin, did not lie inside. Okay, because the question say that given that the origin lies inside the rectangle, so this one is the origin lies on the rectangle, so it is not correct. Okay, so that will complete all the questions that we are supposed to do on the notebook itself. Okay, I will move on to the questions that I've assigned you on the foolscap paper. Okay, let's start with question 6. Question 6 says that the line L is parallel to the line x plus 2y equals to 6. Given that line L passes through the point 3, 4, find the coordinates of the point where L meets the x-axis. Okay, first of all, I rewrite this equation into this form, and I can get the gradient as -half. okay, negative half. Now, since the line passes through the point 3, 4, I can substitute in and I can get my C as 11 over 2. Okay, so the equation of the line is y equals to negative half x plus 11 over 2. Now, they want the coordinates of the point where L meets the x-axis. Where a line meets the x-axis, that means y is 0. So we sub in. When y is 0, I will get x as 11. Therefore, the coordinates will be just 11, 0. Okay, so do not be too anxious to solve it immediately. Do it step by step. Work out the steps in your head first before you attempt the question. Okay, now question 7. The points P, Q and R have coordinates given there. S is the point on the x-axis such that RS is parallel to PQ. Find the coordinates of S. Now we know that S lies on the x-axis. So therefore, I can let S be A0 because the y coordinate is 0 here. Okay. Now I apply the gradient formula. I get this first gradient RS, then I get another gradient for PQ. I will equate these two over here. Okay, I solve this particular equation. I will get your A as equals to 13. Okay, A as equals to 13, and therefore the coordinates of S will be 13, 0. Okay, always read the question carefully whether they want to find the value or they want to find the coordinates. If they want to find the coordinates, you must put it in coordinates form. If not, marks will be deducted. Okay, so this will be your question 7. Next, we move on to question 11. Okay, 11 is a show question. Alright, they say given that the lines are parallel, show that A over B is equals to D over E. Now, they tell you that they are parallel, that means the gradient are the same. Therefore, we write the first equation with y as the subject, and we write the second equation with y as a subject. Okay, then we are going to equate the gradient. These two are the gradient. We equate the gradient, we will get this. Since both sides are negative, we can drop the negative sign. Okay, and we will have this A over B is equals to D over E, and it will be shown. Okay, it will be shown. Alright, now next we go on to question 13. Given that these 3 points are collinear, express C in terms of A and B. Now I am still going to call them A, B, C. So I'm going to show you right one shot. I will use gradient formula. Gradient of AB is this. Okay. Alright, this is the gradient of AB. Okay. Then I'm going to find gradient of BC. I get this. Since they tell you that they are collinear, that means the gradients are the same. I equate the two together as equal. Okay. Then I use cross multiplication. I bring all to one side. And finally, I put C as the subject over here. And I get this. Now note that even if you get until this step, full marks will be awarded. Okay. So you can give the answer as either this or this. It doesn't matter, full marks will be awarded. So the concept down here is that we must get the gradient of AB and the gradient of BC, and we equate the two gradients together to find C in terms of A and B. So that will be your question 13 that is in the exercise 7.1. Now class, I've already completed parallel lines. Okay, make sure you read through angle of inclination again. Alright, and go through this part again. Now if you have questions, you can ask me on Google Meet when I see you the next time. And please make sure you do your homework before you look at the solutions in the video. Alright, that's all for section 7.1. Thank you, class.